So hi guys, and this is the Calculus 11-12 tutorial, where we will teach you about the basic rules of the derivatives. In this tutorial, we will teach you on how to execute the different types of rules in derivatives, and also we will show you on how to apply this in real life. We have different types of rules: the constant rule, constant times a function, the product rule, the quotient rule, the chain rule, and implicit differentiation. Now we will teach you about the different types of rules. So let's get started. The given is f of x equals 17x plus 3. Let's proceed with 17x. X automatically has 1 as its exponent. Subtract the exponent with 1, so it will become 1 minus 1 equals 0. So remove the variable and bring down 17. 3 has no variable, thus it will become 0. So the answer is f prime of x equals 17.
The second rule is constant times a function. The given is f of x equals 9x cubed minus 3x squared. Remember that we always need to subtract the exponent with 1 and after that, bring down 3 beside 9 and multiply it. So it will become 9 times 3x squared, same as 3x squared. Subtract 2 with 1 and bring down 2 beside 3. It will become 3 times 2x. So the answer is f prime of x equals 27 squared minus 6x.
The third rule is the product rule. If f of x equals g of x times k of x, then f prime x equals g of x times k prime x plus k of x times g prime x. Let y equals 4x plus 4 times 6x raised to 2. 4x plus 4 is the g of x and 6x raised to 2 is the k of x. Copy 4x plus 4, then find the derivative of 6x raised to 2, which is 12x. We subtract the exponent with 1, so it becomes 2 minus 1 equals 1. Then we multiply 2 with 6, so it will look like 4x plus 4 times 12x. Next is copy 6x squared. Then find the derivative of 4x plus 4, which is 4. We applied the constant rule here, so we disregard the number without variable and we subtract 1 from the exponent, and it becomes 0. So remove the variable, then after that, we will multiply 4x plus 4 with 12x and 6x squared with 4. So it will become 48x squared plus 48x plus 24x squared. We will add like terms, so the final answer will be 72x squared plus 48x.
Next is quotient rule. We use f prime of x equals k of x times g prime of x minus g of x times k prime of x over k of x squared. The given is y equals 5x squared minus 2x over 6x plus 2. First, copy k of x, which is 6x plus 2, times the derivative of g of x, which is 10x minus 2. It becomes 10x minus 2 because we multiply the exponent 2 with 5 and subtract 1 from the exponent. What happened with 2 is we remove the x because we subtract 1 from the exponent. Next is we copy 5x squared minus 2x and we find the derivative of 6x plus 2, which is 6. We remove the 2 from 6x plus 2 because we apply the constant rule. Then, we divide all of those with 6x plus 2 squared. After that, we multiply 6x plus 2 and 10x minus 2. So, it will be 60x squared plus 8x minus 4. We also multiplied 5x squared minus 2x times 6. So it becomes 30x squared minus 12x. So it will look like 60x squared plus 8x minus 4 minus 30x squared minus 12x over 6x plus 2 squared. The final answer will be y prime equals 30x squared minus 4x minus 4 over 6x plus 2.
Next is chain rule. Let y equals u raised to n, then y prime equals n times u raised to n minus 1 times u. The given is f of x equals x raised to 4 over x plus 1. So the next step is f prime of x equals 4x cubed times x plus 1 raised to negative 1 plus x raised to 4 times x plus 1 raised to negative 2. So the next we're gonna do is 4x cubed times x plus 1 raised to negative 1 minus x raised to 4 times x plus 1 raised to negative 2. So now what gonna do is equals 4x raised to 3 over x plus 1 minus x raised to 4 over x plus 1 raised to 2. Now you're gonna compute the numerator, and this is gonna be 3x raised to 4 plus 4x raised to 3 over x plus 1 raised to 2. Now the answer will be x raised to 3 times 3x plus 4 over x plus 1 raised to 2.
Now, we are done teaching the basic rule of derivatives, and we will now apply it in real life.
This process can continue, but notice that we will get 0 for all derivatives after this point. This set of derivatives leads us to the following fact about the differentiation of polynomials. Let's start this section with the following function. F of x is equals to 5x cubed minus 3x squared plus 10x minus 5. By this point, we should be able to differentiate this function without any problems. Doing this, we get f prime of x is equals to 15x squared minus 6x plus 10. Now, this is a function and so it can be differentiated. Here is the notation that we'll use for that, as well as the derivative. F second derivative of x is equals to f prime of x is equals to 30x minus 6. This is called the second derivative, and f prime of x is now called the first derivative. Again, this is a function, so we can differentiate it again. This will be called the third derivative. Here is that derivative as well as the notation for the third derivative. F second derivative of x is equals to f second derivative of x is equals to third. Continuing, we can differentiate it again. This is called, oddly enough, the fourth derivative. We're also going to be changing notation at this point. We can keep adding on primes, but that will get cumbersome after a while. F fourth derivative of x is equals to f third derivative of x is equals to 0.
So I hope you enjoy our tutorial. And again, this is Calculus 1112. Signing out. Thank you and good night.